Hello and welcome back. So today we're going to talk a little bit more about using similar figures. Now, if you remember, when we said things are similar figures, there are two things they must be. They must have congruent angles, and the corresponding sides must be proportionate. That means that if I set the sides up in a ratio, I get an equivalent ratio. Okay. And now finding this ratio is an art form, kind of. And there's two different ways we can do it, but we'll get to that. The most important thing is us remembering corresponding sides must be proportionate. Okay. So if we look at this problem right here, we see that we have the bigger square and the littler square. And inside that, it tells us specifically they are similar rectangles. So because they're similar rectangles, I know that the sides must be proportionate. Now, do I know that measurement? Am I like pulling out a ruler and saying, hey, this is 2 inches? No, I'm not. I'm using the other sides. And that is called indirect measurement. Indirect measurement is a method of using similar shapes and proportions to find an unknown length or distance. Kind of a fun thing to me. I don't know why I like it so much. I just know that I do. So the first thing is to find our ratios. Okay. Well, I always like to go with the two things I know because it just makes sense to me. So the first thing I see down here on the big rectangle is 84. And I need to set that up as a ratio to the corresponding side of the smaller rectangle. Well, the corresponding side of this smaller rectangle, the window, is going to be right here. And that's 60 centimeters. So I'm going to put it over the 60. And now I need to set up my ratio because I know that these are going to be proportionate. And let's go on ahead and let's look. So I have this side right here that I know, and I know that to be 210 centimeters. And I have this side, which is corresponding, that I do not know. And we're going to call that H because that's what it said to call it, right? So at this point, we have two different ways we can go. The way we've been doing it is we can reduce both, or we can reduce this fraction and find a ratio. So if I wanted to reduce 84 and 60, I can reduce top and bottom by 12. 5 times 12 is 60, and 7 times 12 is 84. Okay? So now that I've got that, I need to find what is the proportion of 7 to 210. So I'm going to ask the question, how many times can 7 fit into 210? Well, 7 goes into 21 3 times. 3 times 7 is 21. Subtract 0, 0. 7 goes into 0, 0. It goes into it 30 times. To be proportionate, I must put a 30 on the bottom. So 5 times 30, 0. H is going to be 150. So our H is 150 if we do the math this way. Now I said there were two different ways that we could do this. So let's make some room here. Let's make some room. We're going to go back to this. We're going to start off with our red. We're going to rewrite our ratios. We're going to pretend like we haven't done that yet. 84 over 60. 210 over, okay. Oh, H. 210 over H. Now, If you remember back, we worked with something that looks similar to this. We used tic-tac-toes for it, and that was the phrase I used. And there was a method that we had for solving for h. Do you remember what it was? That's right, cross multiply and divide. I can do this same math if I cross multiply and then divide. So let's go on ahead and do that. 210 times 60. Well, 0 times anything is 0, but I need my placeholder 0 because this is a 6 that I'm multiplying. So 6 times 0 is 0, 6 times 1 is 6, 6 times 2 is 12. So I have 1,200, or I'm sorry, 12,600, and I now need to divide that by 84. 84 goes into 1, 0 times, 84 goes into 12, 0 times, 84 goes into 126, 1 time. 84, subtract 2, 12 from 8 is 4, bring down the 0, so 420. 84 goes into 420. Well, 5 times 8 is 40, so that's going to be close. 5 times 4 is 0, or 20. Carry the 2. 5 times 8 is 40, plus the 2 is, oh, that's perfect, 420. Bring down the 0. 0, 150. So we have two ways of doing this because we just found that h equals 150. You do whatever way is most comfortable for you. What I find is doing it with the reduction way and finding that ratio is easier if you're doing it on pen and paper without a calculator, whereas cross multiply and divide is much easier if you have a calculator. And in fact, I'll be honest, most of the time I'm walking around, I've got my cell phone on me. It's not a cell phone, but it's a calculator, and my cell phone has a calculator. So cross multiply and divide is what I tend to think of and do. If you're working on the STAR test and you don't have a calculator, reducing might be quicker. Let's look at another example. So again, we have two parallelograms that are similar, and it wants to know the length of PQ. Now remember, we find a line, and let me actually draw that correctly. The line should go over the top. The line PQ is going to be that line between P and Q. And you can see that they've got the small annotation here for the congruent symbol. So those two angles are the same. That tells us that this 16 and this are the same thing. So let's go on ahead and draw that color. Now, because I know that the 16 and this thing, and I want to call this, let's call it X. It's got to have a name. 16 and X. So let's go on ahead and make that ratio. 16X. Well, now I need more corresponding sides. So the other two sides that are corresponding here are the 12 and the 30. Because I put this one on top, the 16 on top, I need to put the 12 on top. Because I got to keep big on top or little on top, but I have to keep the same one on top. And then we're going to go to 30. All right. Now, once again, I can do this either way. I can either cross multiply, divide, or I can reduce. So I'm going to go on ahead and reduce. I can divide out a 6 from both of those, and that's going to give me 2 times 6 is 12, 5 times 6 is 30. All right, so now I need to figure out my relationship here. 2 goes into 16 8 times, so I'm going to put my 8 down here. 5 times 8. What is 5 times 8? 40, right? 40 inches. Spot on. The other thing I could do is I could have cross multiplied and divided. So let's go on ahead and we'll go 16 over x equals 12 over 30. If I cross multiply, 16 times 30, 0 placeholder, 3 times 6 is 8. Carry the 1, 3 times 1 is 3, plus 1 is 4. So I have 480, but now I need to divide by my 12. 12 goes into 48 4 times. 4 times 12 is 48, 0, 0. 12 goes into 0, 0 times. Boom, I get 40 just the same. And I hate to keep rushing, but I'm kind of on a time crunch here. So let's look at one more example. Now remember, We are naming triangles or shapes based on their corners. So triangle RST is going to be the triangle RST. And it is similar to triangle RVW. RVW. So we have the same thing. Now let's set up these proportions, okay? Let's look up. Let's look at the little side. We have 10. And now we need to look at the big side. And when you see problems like this, make sure that you include both parts of the big side. The big side is actually going to be 10 plus 5 or 15, okay? And then we're going to have to do the proportions down here for the other side. So we have 18 for the big side. Big side's going on bottom this time. And D for the top. Now that was the bell, so I kind of got to hurry. So we're only going to do this one way. So I'm going to divide by 5 and 5 to get down to reducing this. 2 times 5 is 10. 3 times 5 is 15. Now I'm going to figure out my relationship here. 3 times 6 is 18, so I put the 6 on top. 2 times 6 is 12. So I know that D is 12. And of course, yes, you could have cross-multiplied and divided. There is one more step I need to tell you, and then we will be done. So that is, if you were to happen to have a triangle that maybe had 100 degrees here and a 40-degree angle here. How many degrees are in a triangle? Did you Google it? How about now? Okay. There are 180 degrees in a triangle. So if I have an unknown here, I know I've got 2 of them, so 100 plus 40, so I just have to subtract 140 from 180. I have 40 degrees left. So this angle is a 40-degree angle. And now if I had another angle down here, another triangle, right? And I told you that this one was 40 and that these are similar, or I'm sorry, not 40. If I told you this was 100 and that these were similar, could you tell me what M was? Well, remember, what was the first rule for similar triangles? Similar triangles must have congruent angles, congruent corresponding angles. Congruent means the same measurement. That means it's going to get the exact same measurement. Hopefully this helps. Sorry, I rushed a little bit trying to get things done before my class shows up. But don't forget to click like, subscribe, hit the notification bell. I'll see you in class on Monday or tomorrow. I'll see you in class.